All right, here we go on day 9. We are still working with circles, and specifically we're dealing with arcs and arc length and even the segments that happen inside of a circle. Circumference, radius. This is a review. This is actually the second half of a review on this circle unit. So let's get started. Look at number 28. Find the circumference of a circle with diameter 16 inches round to the nearest hundredth. Well, we know two formulas for circumference. One of them is circumference is equal to 2 pi times the radius. That's the most common one that we use. But that is the same as circumference equals pi times diameter. Since this particular question mentions diameter, then we should probably use this version of the formula. Okay, so if we go to do that, circumference is equal to pi times 16, which we wouldn't even really write that down. We would write 16 pi. So that is the circumference, and we're supposed to find the circumference. That's our job. So this is the answer. But the answers are all in decimal form, so we go to the TI-30 XS multi-view, and we just type it in, 16 pi. If you hit enter, it just says 16 pi again, but if you hit the toggle button, it switches to decimal form. So we see 50.27. Now, if I look at these answers, all right, see there's, you know what, this is really going to bother me. So, okay, they have 50.27, which is, this is the answer. But I'm really annoyed that they put 50.26 also. They really shouldn't have done that. Now, some people type in 3.14. So I'm curious what will happen if we do 3.14 as an approximation for pi. Okay, that's 50.24, so that's further away. So, okay, so this question is clearly testing whether or not you know how to round properly. So, and some of my kids don't. So let me just re-emphasize to you, if we're going to round properly to the nearest hundredth, that's 2 decimal places, that means we want to stop it here, but we look to the next number over to decide if I'm going to keep the 6 or go the next number higher. If this next number is 5 or greater, then this has to go up. So since this is a 5, we go to 27. So that's why the correct answer is 50.27. The answer is B. Okay, kind of lame that they put it that close though. Anyway, what are you going to do? Number 9, find the radius of a circle with circumference 60 m. Now, look, if they give you the circumference, use the circumference formula. So I'm going to use the version of the formula that goes 2 pi r, because r is the radius and we're supposed to find the radius. So they gave us that the circumference is 60 meters, so just put that in. So this becomes 60 is equal to 2 pi times the radius. If I divide both sides by 2 pi, okay, so these cancel each other out. So again, this is really the answer. Okay, I could reduce this to 30 over pi, but again, we have decimals. So to the calculator, 60 over 2 pi. Fraction mode right away, 60 over 2 pi. Just type it right in there. Okay, so we get 9.55. Again, we round this up because the next number is a 9. So 9.55. That's what I'm looking for. And there it is, A. Okay, number 30. Okay, find the circumference of the circle round to the nearest hundredth. All right, we're supposed to find the circumference. We're given the radius. So let's just go ahead and do circumference is equal to 2 pi r. So that's just going to be 2 pi times 3, which is 6 pi. So that is the answer. That's the circumference. We just need to convert it to a decimal. So 6 pi. So that's 18.85. Round up because the next number is a 9. So 18.85. And there it is, 18.85 centimeters. That answer is D. All right. Number 31, find the length of arc AB. Okay, here we go. So this is slightly more challenging. Arc length. Anytime you're dealing with arc length, you're probably going to be using the model, setting up an equation that of the form part over whole is equal to part over whole. The part over whole on the right hand side is degrees, and the part over whole on the left hand side is length. Okay, so that's what we're going to do. So let's get started. So on the right hand side, part over whole, degrees. The partial degrees are right here, 125. Okay, basically the arc measure. The total degrees, of course, are 360. Now we will do part over whole length. Well, the length of the arc AB, that's what we're supposed to find. Okay, the partial length here, that's the unknown. So we'll call that x. Now, the total length, the whole part over whole, the whole length is the circumference. So this in the denominator on the left will always be the circumference. So just like we calculated the circumference up here, we're going to calculate the circumference right now. Okay, so I'm going to just calculate that off to the side. I'll put it right here. Circumference should equal 2 pi r. So that means the circumference is 2 pi 6, because there's my radius. 2 times 6 is 12, so my circumference is 12 pi. Okay, so I'm going to take that and put it where it goes. The whole length, the circumference, is 12 pi. So, partial degrees over the total degrees. Partial length over the whole length, the circumference. So now all I have to do is cross multiply, and that's going to find x for me, and I'm golden. Okay, I highly recommend reducing this fraction first. 125 over 360 with the TI-30. It's easy. Just type it in. Whoops. Okay, I said it was easy, and then I messed it up. Okay, awkward. 125 over 360. Okay, so that's 25 over 72. Let's go with that. So I have x over 12 pi is equal to 25 over 72. Is that what I said? Yes, it is. All right, now cross multiply. So if we cross multiply this mess, okay, we're going to get 72x. Let me draw a line here. I think I'll even change colors. All right, I'm just bringing this up to the top. So this is going to be 72x equals. Now if I do 25 times 12 pi, now will it give me a decimal if I put the pi right in here? No, okay. 25 times 12 pi is 300 pi. So I have 72x is equal to 300 pi. So I just need to divide both sides by 72. Okay, and I want a decimal anyway, so I can just put all this in my calculator. So 300 pi divided by 72. Okay, they reduced it for me first. If I wanted an exact answer, there it would be. But we need the decimal. So that's 13.09. Got to round that up because the next number is a 9. So 13.09. Oh, well, they want the nearest tenth this time, so 13.1. Okay, and there it is. 13.1, so the answer is C. Okay. Alrighty then. Let's try number 32. Find the radius of this circle, round to the nearest tenth. Now, they gave us the arc length this time. Last time we were looking for the arc length. This time they gave it to us. So, you know, this is not degrees or anything. This is the arc length. If it were degrees, it would be 75. So, as soon as you see arc length, go ahead and get ready to do part over whole equals part over whole, just like we did before. So like I said, when we do part over whole on the right hand side, it will be degrees, part over whole degrees. The partial degrees are 75 degrees. You know, that's the same as the arc measure. So 75 degrees over 360. Now on the left side we have length. We need the partial length divided by the whole length, which is the circumference. Well, the partial length is given. It's the 32.3. So right here will be our 32.3, our partial length. Now the whole length, please don't put an X right here, because we're looking for the radius. We'll have to put a C here, because that is the circumference, and so we're going to have to find the circumference first, and then go on to find the radius afterwards. So don't put X, or you're going to think that that is the answer, and it is not. So we're going to reduce and cross multiply. So 75 over 360. So 75 over 360, it's 5 over 24. Okay, so I've got 32.3 over the circumference is equal to 5 over 24. Is that what I said? Yes, it is. So cross multiply. So if I multiply this way, I will have 5C. If I multiply this way, 24 times 32.3. Okay, so 24 times 32.3. I get 775.2. 775.2. Time to divide by 5. Divide by 5. Okay, and I'm going to get whatever I get, man. Let's see. So I already have that there. It's already sitting there. So if I want to divide by 5, I can go straight to this button. I don't need to retype it. I can just go divided by 5. That answer is this previous answer. So I get 155.04. Please don't round this. Keep it all. All right, so the circumference is 155.04. Okay, that's good to know, but again, that is not the answer. Okay, that is the circumference, and we will use it right now. Now, remember what we're actually supposed to find is the radius. So, I feel like changing colors to blue. We have the circumference, we're looking for the radius. We've done problems like this just a second ago. Where was it? See, like number 29. If I wanted to find the radius and I had the circumference, I just took the circumference formula and I plugged that circumference in and I divided it and I got the radius. So we're just going to do this again. Okay, so the circumference is, well, let me write it over here. The circumference is 2 pi r. So, well, the circumference is now 155.04. So I can just plug that in. So this will become 155.04 is equal to 2 pi r. So we want that radius, all right? That's what we're supposed to find. So let's go ahead and divide both sides by 2 pi. Okay, watch out for the common mistake be careful about how you put this in your calculator. Okay, do you remember, people that are in my class in real life, I warned you, if you have two options, I would recommend typing this in as a fraction. So if you take my advice, you will go straight into fraction mode and type 155.04 over 2 pi. This is the safest thing to do. Okay, you hit enter and we find that it is 24.68. Next number is 5, got to round up. So 24.68. Oh, nearest tenth. Okay, 1 decimal place. So 24.7. If we round here, we've got to round that up because that's 7. So 24.7. So that is the answer. Okay, now let me emphasize to you the mistake that you have to avoid. Okay, that's the safest thing to do. Now, some kids will do this. Instead of typing the fraction, they will want to go 155.04 divided by 2 pi, like this. But if you type this in, you do not get 24.7. You get this big number, it's completely wrong. So this is the common mistake. I see this over and over again, and I don't want you to make this mistake. The reason why you're getting a different answer is because of the order of operations. Your calculator is dividing by 2 first, and then it's multiplying by pi. And that's not what you want. You want to divide by the 2 and the pi. So if you want to do it that way, you have to type it in this way, 155.04 divided by, all that's fine. But if you want to use this kind of a symbol, you have to type in 2 pi in parentheses. It has to be in parentheses, so that way you're dividing by all of it, not just the 2. And now you see we'll get the same 24.7 that we got when we did it the fraction way. Okay, so watch out for that. Anyway, the answer was A. Okay, look at number 33. Find the length of a 40-degree arc in a circle with radius 4. They didn't give us a picture, but we don't really need it. You see that we're talking about the length of an arc. Okay, like I mentioned before, as soon as you see arc length, see here we're given arc length. Here we're told to find the arc length. Okay, in number 31, we were told to find the arc length. Anytime arc length is involved, that's when you should go straight to part over whole equals part over whole. So let's do that now. Okay, so if we do part over whole, I feel like I want to set it up over here. No. You know what? Let me blow this up bigger. I'm going to need more space to work in. Okay, that might be too big. Let's see. Okay, so we're going to do part over whole equals part over whole. So here we go. Like we've done many times before, we're going to do part over whole degrees over here. So 40 degrees, obviously that is the partial degrees, and the total degrees are 360. Now we're supposed to find the length of the arc. So the arc length is the partial length, because the total length is the circumference, and that's what should go here. So the circumference, let's calculate that off to the side. So the circumference, of course, is 2 pi times the radius. They gave us that the radius is 4. So the circumference is 2 pi 4. 2 times 4 is 8. So that's 8 pi. So there's my circumference. I'm going to take that and put it where it goes. Okay, so that's going to be my 8 pi is the circumference. Part over whole, the whole length is the circumference. So now we're just going to reduce and cross multiply like we've done many times before. Okay, so if I do this, 40 over 360, this is going to be 1/9, but if you don't believe me, 40 over 360, okay, 1/9. So I really recommend you always reduce like I just did. You won't get the wrong answer if you're very careful, even if you don't reduce, but with bigger numbers, you're more likely to make a mistake. Okay, so we have the 1/9. So then we're just going to cross multiply. So going this diagonal, that's going to be 9x equals, and going this diagonal, 1 times 8 pi is just 8 pi. So if I divide both sides by 9 at this point, okay, those 9s cancel out. All right, and that just leaves me with x equals 8 pi over 9. And this time the answers are in exact form, no decimals, so it's important that we kept everything tidy. So 8 pi over 9. So that's why this is my answer. A. All right, that's how we do that one. So let's move on. Okay, it just gets more and more interesting from there. All right, this is too big. Better zoom out. All right, number 34. Use the diagram given information to find the diameter. Okay, so this is our target. We're trying to find the diameter. The diameter is this guy right here. Okay, that is the diameter. So that is what we're trying to find. We're given BR, we're given D. All right, so I'm just going to call this whole thing X. So X is this entire red, the diameter. Now, we've done lots of different kinds of problems, part over whole and all that, but this problem does not involve arc length. There are no arcs in here anywhere. It's all segments. So they gave us that BR, let me go back to smaller. BR is 40. So this length right here is 40 centimeters. And they gave us that DR is 48. So this is 48. So, ladies and gentlemen, this is back to a different kind of situation. Let's look at those formulas we will not be given. In this particular unit, this was the last unit with the arcs and angles and inscribed. There's always some review questions you have to deal with. But we've moved on to working with segment lengths pertaining to circles inside and out. And so get these formulas back in the front of your brain. You must memorize them. If we're inside the circle completely, it's part times part equals part times part. A times B equals X times Y. If you are having these secant segments going outside of the circle, it's part, the outer part times the whole thing equals the outer part times the whole thing. Part times whole equals part times whole. So it would be A times A plus B, and X equals X times X plus Y, like I've shown here. So we're going to be using one of these. Which is it? Well, you can see that the segments are going outside of the circle. So we're going to do that part times whole equals part times whole version. So, okay, so we're doing this. Part times whole equals part times whole. And the part has to be the outer part, like the 40 and the 48. So, okay, so part times whole, looking at this segment up here, is going to be 40 times X plus 40. Okay, 40 is the part, X plus 40 is the whole. And that should equal part times whole. Now, this is that special case. Looking at this, we have this part and then the whole thing, but on this particular problem, because it is a tangent, the 48 is the part and the whole. It's both. So when I do part times whole on the right, I'm going to wind up doing 48 for the part and then 48 again for the whole. So watch out for that. So we'll wind up doing a little distributive property right now. So that's going to give me 40x plus, okay, 1,600 equals, right, 48 times 48, or I could have done 48 squared. It's equal to 2,304. 2,304. Okay, so we just need to solve this. So subtract 1,600 from both sides. Okay, so I can just do minus 1,600. So I get 704. So that means I have 40x is equal to 704. Of course, now I will divide both sides by 40 to get x by itself. So back into my calculator, I can just do divided by 40. All right, because 704 is already there. So I can just go divided by 40. Okay, I get 17.6. Alrighty then. So x is equal to 17.6. Now x, just to go back and check, we were supposed to find the diameter. X was the diameter. So yeah, that's the answer. Don't forget the units. All right, 17.6. These are all centimeters. Okay, that's how you do number 34. Let's move on to number 35. Okay. All right, we've got this picture. MR is 75. So, wow. Okay, so MR, let me be clear. MR is the entire length from here all the way to here. So that is 75. Good to know. Now, DR is 60. Okay, so that's just this part from here to here is 60. All right, it's just this. All right, so I've got this and this. Maybe I should color coordinate this. So these are the two numbers we're given. We're given this whole red length is 75. We're given this outer part here is 60. Now what are we supposed to find? The length of BR. Okay, I'll mark that here in green. Okay, this is what we're supposed to find, BR. Okay, how am I going to do that? Well, we're going to use the same sort of technology that we were using on number 34. All right, you can see it's almost the same picture. I mean, it really kind of is the same picture. I literally cut and pasted it. Who am I kidding? But, so this is that same part times whole equals part times whole situation. So just be very careful. For some reason, kids get very confused when I give them the whole. They keep wanting to do x and then like x plus 75, or I've seen kids do 75 minus x or something. But no, that's not what's going to be happening. If I'm going to sit here and do part times whole, okay, is equal to part times whole. Okay, let's really think about it. When I look at this red area, the part, of course, has to be the outer part. What's the outer part of this secant segment? The outer part is x. All right, there it is. That's the outer part. Now, what is the whole length of the secant segment. I'm doing part times whole. What is the whole? The whole is 75. It's not 75 plus x or 75 minus x or anything like that. The whole, we're given that MR is 75, plain and simple. 75 is the whole, so it's x times 75. And then down here, just like before, this 60 is the part and the whole. So the part is 60 and the whole is also 60. So this is how you set it up. Problems like this are the most commonly missed problems on the test historically. So please be extra careful with your part whole. So anyway, back down to business. I'm going to stay red. So this will be 75x equals, all right, 3,600. So we're just going to divide both sides by 75. Okay, so 3,600 divided by 75. That's 48. Okay, so that's our BR. So that's answer number 35. Okay, number 36. All right, kids have trouble with problems like these because there are two problems in one. So you just have to focus on one problem at a time. I would actually like to find the y value first because hopefully you will notice that you see the 64 over here and the y plus 8 over here. Remember, when we have those tangent segments like this, they're always equal when they're both coming from a common point. So that means we're just going to have y plus 8 is equal to 64. So this is actually really simple. Subtract 8 from both sides. Okay, so of course we're going to have 56. All right, so the y value is 56. Okay, so that's fine. So we already knew that if this is 64 over here, then this other red side is also 64. I mean, that's how we did the problem. So this is 64, that's 64. Also, the radii. So if this is 48, then this is 48. You can look at it that way too. We also know from previous units that the radius and the tangent are always perpendicular. So I could do the Pythagorean theorem, is what I'm setting up for. So I mean, look at this. Let's see. Look at this hypotenuse, which I'm coloring in blue. Okay, I'm going to call that C. Now this C is the entire KR. So I'm really working on this third one right here. But that C is just the hypotenuse of this triangle. Let me go ahead and color in the third side here. All right, so I'm dealing with this triangle right here. So I'm just going to do leg squared plus leg squared equals hypotenuse squared. So let's do that. So I'm just going to do 48 squared plus 64 squared is equal to C squared. All right, so if we just wind up taking the square root of both sides, okay, then that should give me the answer. All right, notice you can just type the entire thing into your TI-30XS multi-view, and you get 80. Okay, so C is 80. But remember that this C is KR. This hypotenuse is KR. So that is 80. And that just leaves X. But look, if this whole thing is 80, you know what I mean, from here to here, if this is 80, But look, see these 48s? We know that the radii will always be the same. So, in other words, if this is 48, then this will be 48, kind of from here to here. Also, is 48. So if the whole thing is 80 and this is 48, how do you think I'm going to find x? Yeah, x should be, if I take that 80, which is the whole thing, and subtract the 48, that should give me x. All right, because that's what's left. So, of course, that's just going to be 32. Okay, and by the way, this up here, well, let me write that down. So that's 32, and that's really the end of the problem. I just feel like going back and writing that this C was KR for the record. All right, moving on. Okay, let's wrap this thing up. I'm hoping these ones down here are super easy, especially radius diameter, because, you know, we all know that if you have a circle such as this, and if you imagine that this is the center right here, okay, then, you know, we've got the diameter would be like so. Okay, so this is the diameter. Let's go ahead and make it red. All right, that's the diameter. Now, if that's the diameter, then this is the radius. So we got the radius is like from here to here, and then the diameter is the whole thing. Okay, so if the radius is 13, what's the diameter going to be? 26. Okay. Wait, I went the wrong way. Whoops. If the radius is 13, the diameter is 26. Okay, if the diameter is 24, what's the radius going to be? 12. Okay, so that's all well and good. Now the circumference, remember that we can think of the circumference as either 2 pi times the radius or pi times the diameter. Both of these mean the same thing. So if the diameter is 26, then the circumference is going to be 26 pi. All right, it's pi d, pi times the diameter. If the diameter is 24, then the circumference is just going to be 24 pi. Okay, pi times the diameter. And I should put the units in here. And that was a messy pi. Let me try that again. Okay, 24 pi centimeters. Okay, so the only one that takes any thought at all is when you're given the circumference. But, you know, look, if the circumference is pi times the diameter, so that means this thing sitting right there, you know, if there's a pi in there, is going to be the diameter. That means that here the diameter is 50, which means that the radius is 25, because it's got to be half that. Okay, so I'm hoping this chart business is going to be real simple for you guys. Okay, anyway, number 40. So both of these are review questions, but there will always be some review questions on the test. So remember that if you have an inscribed angle like this, the angle is half the arc. So one way to do this would be to go, okay, if this angle is 125, I would have to double it, and that would be this arc. I'm going to do it in green for right now. So this green arc would be 250. All right, so this would be 250 degrees because I doubled this. But if I want to find arc AB, okay, which is this side over here, then I need to subtract from 360. So I'm doing 360 minus 250, so that would be 110 degrees. Okay, and finally number 41. What's the measure of an angle inscribed in a circle if the intercepted arc is 64? So this is mostly a question of your vocabulary. Do you know the vocabulary? So, this is what they're describing. So we've got a circle, and then we've got this angle that's inscribed in a circle. Okay, and an inscribed angle in a circle is like this type of a deal. Okay, so there's my angle inscribed in a circle. And we are being asked for the measure of the angle. All right, so I could call it theta. If we are given that the intercepted arc, and this would be the intercepted arc. Whoa, messed that up. Let me try that again. But this would be the intercepted arc over here. And we're told that the intercepted arc is 64 degrees. So the question is, if this is 64 degrees, then what is going to be the measure of the angle? And if you understand all that vocabulary, then you probably understand, again, that the inscribed angle is going to be half of the intercepted arc. So that means that theta will be 32 degrees. Okay, it's half. And that's it. So that's a nice little review of the concepts from this unit with the arcs and the chords and everything else. All right, please give me a thumbs up. Give me that like. Show me that you appreciate what I do, and I appreciate you as well. And I'll see you on the next video.